Just learn what an exception is, and then checked exception and runtime exception. So these exceptions, we ultimately recognize them for what they are, is to be able to catch or declare data. And that means that ultimately we have to deal with it. And how do we do that? So this section is to recognize these 5 keywords. The first keyword is called try. So what's inside is the code that might raise the code that could trigger an exception. The catches refers to the capture. Finally means final. So throw is throwing an exception. And throws is to declare an exception. So how do we use these keywords? How do we use them? Let's start with the literal meaning of the word. Then we start with the literal meaning of the word. Try. We have possible exception code into this try. And try it first. And then start to catch the exception code in the try. And the finally is whether you catch it or not. I'll be able to execute it eventually. And throw means throwing it. In other words, I can create an exception manually. You can see the Chinese explanation. For throwing an actual exception, it can be thrown as a separate statement. Throws is on the method declaration. In other words, you can declare, I have an exception in this method. These 5 keywords are then used. And then we'll try to handle exceptions. So to handle an exception is to use the try-catch statement. Is where we try to put some of the that might be an exception to put in the try. And the start is to catch the exception. Is to make sure that our program works. So let's look at one syntax of it. The try is followed by curly braces. Inside is a code box. And inside the start is the exception class that we can catch. And the curly brackets after the opening parenthesis is how I'm going to handle. How I handle it after I replenish it. Okay, so this is how an way of handling exceptions. So let's go to demonstrate this with IDWA. Click on a test. I'm going to use the same used arithmetic exception. A divided by b. Is it possible that there is an anomaly? So look at this. When we go to adjust this unit, if what you pass is not 0, then this time we have no problem. Print this is the subsequent code execution. Then at this point we run the results. You see if the subsequent code is executed. So if this is 0, then this has been shown to him before. Then at this point the next is not able to run. Good. At this point, we can use try to enclose the potential code. Be careful to throw this piece of content into it. Okay, when it's done, start catch it. What's the exception class? Then we take this class and catch it. Declare an object. At this point, we're catching here. We can print it later. The divisor is 0. If there's an exception, the divisor is 0. Okay, at this point we execute. What's the order in which they'll appear? Wouldn't they go to the beginning of this? An exception occurs and the divisor is 0. Then he can ensure that the program will go down. Right, without affecting the rest of the code. This is the basic syntax of the try-catch. Then look at some of his notes. See that the try-catch code is a block. It's required. And finally, blocks are optional. Third, you can write more than one catch block. But the one that catches the superclass exception must come after the subclass. When learning the architecture of exceptions, is there an inheritance structure between exceptions? If I write a runtime exception, it's okay to put it at the back. But if I put it in the front, right? And put it on top of the subclass. That's not right. Think about it. Is it because when we execute this block, when an exception occurs, it's going to look for the first start? And at that point, you've already covered the next subclasses. The following catch would have no chance of being executed. So this is syntactically incorrect. That's why we should put this superclass to the bottom. That means, when will the code below be executed? Is when the above is not satisfied. Then I'll do the following. At this point we know the exception at this point is a null pointer. Then the first catch can't be caught. Then it'll look for the second catch. Okay to run. You see, at this point, he won't execute this statement. It's a runtime exception. So no matter what, is he guaranteed to execute it, but if you have an exception, it's not even catched. What should we do then? Let's say we change this to a null pointer. It's not a null pointer. Then calculate another exception. Okay, let's get rid of this one. The reindex is not an arithmetic exception, nor a null pointer extension. At this point, when we proceed, you can see, is not going to burst the exception again. Equivalent to these to catch are not caught. Then the exception still exists. JVM will handle it in a simpler and more brutal way. The way JVM handles it is simpler and rougher. It just stops the program abnormally and print it in red on the console. So the subsequent code will also affect the code. In the end, no matter whether this exception appears or not, we can guarantee the execution of subsequent code. So there's no need to memorize. So you don't need to memorize a lot of exception class names. The catch block must come after the try code. That's normal. Okay, let's take a look at the flow of execution. The try block is executed first, so if an exception occurs in the try block, he'll go to the catch to look for it. If it's caught at the beginning, so if there's no exception in the middle of the try, then the program is running normally. Show him. If there are no exceptions here, notice how I'm ignoring all the exception statements. At this point, is not the catch inside. The statement will not be executed, and just run the subsequent code. This is the basic syntax of the try-catch syntax, and how it is used. Next, we will learn another keyword finally. Finally, as the name suggests, means final. So the statements in finally will be executed eventually. So look at his syntax structure. That means we can use try and finally, or we can use a combination of try, catch, and finally. So how does he explain? How does he explain the try? Or does he put a block of code that could have an exception, and then the start is used to catch this exception class? You can write more than one at the beginning, then at the end you can add a finally. And the block of code inside that finally, that's the final block of code. It will be executed eventually. So let's go through a case to show him. Let's stick with the previous example. Let's take this method first. At this time we cannot put this. There may be an exception code. And then use try, wrapped up in parentheses. Some students feel it's a pain in the ass when writing. Then there is no shortcut. Yes, there is. Let me show you. At the beginning of this, we recommend that you learn to write by hand. So how to write like this? Select it Ctrl Alt plus T. Then this is the code that might have an exception. I'll type one here. You can guess the order of execution. Okay, then print it to here. Okay, then pay attention. At this point we end up executing a, let's say a 4. Then we can follow this up with a finally is the one that will be executed eventually. For example 3. Okay, pay attention. We are now. This unit has an exception. So I'm running. Think about the order in which it will be executed. Then we can analyze it first. When an exception occurs in my unit, is not directly start to find the catch. That means we'll find the catch at this point. And since we've already catched, so the program does not affect the final execution. Let's take a look at the result. What if I have an exception? It cannot catch. You say with the null pointer extension. The null pointer extension can't catch this. This is called an arithmetic exception. Because the two of them are at the same level, what will be the order of execution at this point? Well, first of all, the first one will definitely not be executed. Because this code has an exception. After we get here, when you find you can't catch it. So at this point, since your side, the exception was not caught. So the 4 can't be executed. Okay, then a 3 will appear. As you can see, we don't care if the exception is catched or not. We're going to end up executing the code block and finally. This is one of the functions of finally. Okay, back to the PowerPoint. You can see the execution sequence flow has changed from the previous one. If there is no exception, then it's executed directly into the finally, and then executes the rest of the. If there is an exception, we will first look at the type of the parameter in the code block, whether it matches the type of the parameter in the code block. Okay, so let's finish with a demonstration. When he doesn't have an exception. Okay, let's remove this sentence. Then there's no exception. So first of all, this one won't be executed. Then the start block won't be executed. Then finally we'll execute 134. Let's see what happens. That's a basic use of finally. Next, we'll learn another keyword. Throw is a second way to handle exceptions. It's meant to be a way of naming exceptions. Okay, back to the code. You see a demo here. Then create a test class for this demo. The same method that you just wrote. Previously written this method to take over. Okay, so at this point, we know that this block of code is not likely to have an exception. For example, there is no exception in this block. That means that this method tells the caller that there might be an exception. So that's why you need to handle this method. There are two ways to handle this. The first one, you can do a try-catch here. Processing. Okay, let's look at the first way. After processing, well, print it out. Okay, and then we go to execute. Well, see if it's a 1 and a 3. That is to say that at this time this exception is not appearing. So what we execute is not 1 and 3. Then if there is an exception O, then the result of this execution must be to and 3. That means when we add the throws, I have to handle this exception. Then there is another way. Let's look at the second way. I'll get rid of this piece. Okay, here it is. Okay, at this point, let's say 2. There may be an exception. This time I can also choose. Let him also throws. That is, in this position, I'll declare this 2. The exception is gone. Let's go to the execution. At this time he is able to pass the mutation. But once we have an exception, the exception is not yet handled. Throws is called a declarative exception. What's the purpose of a declared exception? It allows checked exceptions. That's why we're here. Let him pass the check. That's what I mean. Okay, let's go back to the PowerPoint. So you can see this text. In the actual development, most of the time we call methods written by others. But we don't know if there are any exceptions in other people's methods. In this case, we use the keyword of throws to declare the possible exceptions of the method, so that when the caller calls the method, we'll know that there is an exception. And we handle it in two ways. One is to put try-catch, or to put the try-catch, and finally, there is another way is throws to declare. That's the way it's going to be declared, is that it's making this statement. Doesn't really handle it. Instead, it's giving the exception back to the caller, which is JVM. So that's why, for this declaration to be an exception, it's only useful for getting through the check and informs the caller. It doesn't really handle it. Going back to the PowerPoint, they declare this exception, and they can declare more than one. So this time can also be written in this position. For example, when I declare an exception, multiple exceptions can be declared this way. Okay, then we'll see the handling of his exceptions. This has already been demonstrated. If you don't handle it, he won't execute, right? And then we've got two examples. One is the try-catch approach. One is the way to declare directly to the outside. So that's how you learn the slush keyword. Throws keyword.